Hello everyone. In this video we will discuss what elasticity of demand is and how the shape of a demand curve can affect elasticity. Our main focus today is on downward sloping linear demand curves. According to the law of demand, when price falls, quantity demanded increases. But how much does it increase? To answer this how much question, economists use the concept of elasticity. Let us understand this with the help of a graph. On one axis we have price of pizza and on the other axis we have quantity of pizza. Now we draw a downward sloping linear demand curve and select a point on it. Point A tells us that when the price is 16, quantity demanded is 2. Now we reduce the price from 16 to 10 and move along the demand curve to a new point. At point B, price is 10 and quantity demanded is 5. As you can see, a change in price has caused a change in quantity demanded. So far we have described this change in units, but elasticity uses percentage changes. Elasticity of demand helps us analyze how much quantity demanded changes in percentage terms when price changes by a certain percentage, such as 1%, 2%, or 5%. A simple formula for elasticity of demand is shown on the screen. Elasticity of demand is equal to percentage change in quantity demanded divided by percentage change in price. Expanding the formula, percentage change in quantity demanded is equal to new quantity minus old quantity divided by old quantity. Percentage change in price is equal to new price minus old price divided by old price. Elasticity of demand is the ratio of these two percentage changes. Now let us substitute the values. We will treat point A as the old point and point B as the new point. In other words, price and quantity demanded have changed from point A to point B. After substituting the value into the formula, we obtain an elasticity of -4. The negative sign indicates that price and quantity demanded move in opposite directions. As price falls, quantity demanded rises, and as price rises, quantity demanded falls. Because this inverse relationship is true for most demand curves, the negative sign usually provides little additional information. Economists are often more interested in the responsiveness of quantity demanded than in the direction of the relationship. Therefore, elasticity of demand is commonly reported in absolute value terms. In our example, we say that the elasticity is 4. Before moving on, notice that we treated point A as the old point and point B as the new point. In other words, price and quantity demanded have changed from point A to point B. If we reverse the order and treat point B as the old point and point A as the new point, the elasticity value changes. We will demonstrate this shortly. To avoid this directional bias problem, economists often use the midpoint formula. However, to keep the analysis simple, we will continue using our current percentage change formula. Now let us examine how different demand curve shapes affect elasticity. We add two more downward sloping linear demand curves. D3, the yellow curve, is steeper than the other two curves, while D2, the green curve, is flatter than the other two curves. At this point, all three curves intersect and share the same price and quantity combination. The price is 16 and the quantity is 2. Now we reduce the price from 16 to 10 and move along all three curves. Notice that the price change is identical for all three curves. In each case, the price falls from 16 to 10. However, the change in quantity demanded differs across the curves. For the steeper yellow curve, quantity increases from 2 to 3. At this point, quantity demanded responds relatively little to the price change, so demand is relatively inelastic. For the blue curve, quantity increases from 2 to 5. Here, quantity demanded responds more than on the yellow curve, so the blue curve is more elastic compared to the yellow curve. For the green curve, quantity increases from 2 to 8. Here, quantity demanded responds the most among all three curves. So the green curve is more elastic compared to both the yellow and blue curves. If we now express these changes in percentage terms using the elasticity formula, we can clearly calculate and compare the elasticity of demand for each curve. It is important to remember that steepness alone does not determine elasticity. In our example, we are comparing different demand curves at the same point. We say that a curve is steeper or flatter when we compare it with another curve. For example, here we are comparing the yellow curve with the blue and green curves. Steepness is therefore a relative measure. The yellow curve is steeper relative to the blue and green curves, while the green curve is flatter relative to the yellow and the blue curves. In real, elasticity varies at different points along the same downward sloping linear demand curve. Let us see this numerically. Consider our original demand curve, D1. We select 3 points. At point A, price is 16, quantity is 2. At point B, price is 10, quantity is 5. This is the midpoint of the curve. And at point C, price is 4, quantity is 8. First, let us calculate elasticity between point C and B. We treat point C as the old point and point B as the new point. Using our formula, we obtain an elasticity of 0.25. Earlier, we calculated elasticity between point A and B and obtain a value of 4. Now we reverse the order and calculate elasticity again, treating point B as old and point A as the new point. This time elasticity equals 1. As you can see, when we treated point A as the old point and point B as the new point, elasticity was 4. When we reversed the points and treated point B as old and point A as new, elasticity became 1. This shows that the simple percentage change method can give different elasticity values depending on which point we treat as old and which point we treat as new. We also found that elasticity between point C and point B is 0.25. This shows that even on the same linear demand curve where slope is constant, elasticity can differ from one point to another. Generally, for a downward sloping linear demand curve, elasticity is equal to 1 at the geometric midpoint. Above the midpoint, elasticity is greater than 1, while below the midpoint, elasticity is less than 1. As we move downward along the demand curve, elasticity decreases continuously, meaning that quantity demanded becomes less responsive to change in price. Conversely, as we move upward along the same demand curve, elasticity increases, meaning that quantity demanded becomes more responsive to price change. This variation occurs continuously along the entire demand curve. Why does this happen? At higher prices, the quantity demanded is relatively small. A given change in quantity represents a large percentage change in quantity. At the same time, the percentage change in price is relatively small. As a result, demand is more elastic in this region. At lower prices, the quantity demanded is relatively large. Therefore, the same change in quantity represents a small percentage change in quantity, while the percentage change in price is relatively large. As a result, demand is less elastic in this region. This pattern is specific to downward sloping linear demand curves. Other types of demand curves, such as nonlinear demand curve, may show different elasticity patterns. It is important to distinguish between slope and elasticity. Slope measures the steepness of the curve, whereas elasticity measures how responsive quantity demanded is to change in price. Therefore, slope and elasticity are not the same thing.